our final video for Chapter 2. Now, Chapter 2 is dealing with two variable inequalities. That means we have an x and y inequality. Before, we just had an x. Also, with two variable inequalities, we're going to be graphing linear equations and absolute value equations. The things that we have learned about in previous units, we're going to apply today. So this is what an inequality for two variable and a linear equation. Couple of things here. If you want to write this down, you can. You do not have to. In this equation, I can tell you that this equation was a y is greater than, because it's above the line, the shading is above the line, and it's dotted. In this equation, this would be a y is less than or equal to. The shading's below the line, so it's less than, and it's or equal to because it's a solid line. So we're going to get into how we write equations and graphing in this video. So graphing an inequality. First thing I'm going to do is from my equation, I'm going to pick up that my slope is equal to 3. That's the same thing as 3 over 1. I like to write it as a fraction. It helps me. My b or my y-intercept is -1. I also am going to look at my inequality sign, and it says greater than. So I'm going to say write dotted to remind me that my line should be dotted, and would be above. Greater than would be above the line. So first I'm going to graph my line. My b is at -1, so I'm going to plot my y-intercept. And then from there I move +3, 1, 2, 3 over 1. Rise over 1. Or else I could have gone down 1, 2, 3 and left 1. Now that I have my 3 points, I'm going to make my dotted line. And this says above, so I'm going to shade above this line. And that's all I do. So again, make sure you state your slope, y-intercept, if it should be dotted or solid, and above or below. Right now I want you to pause the video and try to graph this by yourself. If this is still confusing to you, you should still, before looking at the answer, state the slope, y-intercept, and if it's dotted or solid, and if it's shaded above or below. My slope is -2, my y-intercept is 1, and it's solid because there's a line underneath. Solid would be a line. Now that I have my line, it's above because y is greater than this line, so I have to shade above the line. And that is your answer. Again, try to attempt this problem by yourself. If nothing else, state the y-intercept and slope and above solid. So this is what your graph should look like. Slope of -2, y-intercept of 1. It should be dotted because there's no line, and below. One thing is, I would always write this down for each problem that you're doing, because if for some reason, if I cannot tell on your graph if your graph is dotted, I will use this as a reference to see. If your line looks like this, and you said, oh, it's dotted, but you didn't write below, I would mark that off again. So if for some reason I can't look at your graph, I will always look at what you write as a reference. So now I have absolute value. The first thing you want to do is get the y by itself. So I'm going to subtract my 1, subtract my 1. So now I have y is less, or I should say -y is less than my absolute value of x plus 2, and then I have a -1. The other thing I have to do is divide by -1. So I'm going to divide each term by -1. So the equation I'm actually dealing with here is going to be y. Since I'm divided by a negative, I have to flip my sign. So I'm going to flip my sign. I'm going to have a -1 out in front here. And then my absolute value of x plus 2. And then this becomes a +1. So now I use this to help me graph. I'm going to just draw my graph. I'm going to state my transformation. This 2 is going to move it left 2. This 1 is going to move it up 1. This -1 in front is going to have a reflect over the x-axis. So I'm going to write out what my new vertex would be. So left 2 would be a -2, up 1 is 1, and my slope here is going to be 1. But I have to make sure to include it's reflective of the x-axis. So first I'm going to plot my point left 2, up 1, and then my slope down 1 over 1, down 1 over 1. Now that I have my 3 dots, I go back to my original equation. This now will tell me I should have written that it's going to be dotted, and it's also going to be above the line. So my dotted line would look like this. And above this line is everything above here, because y is greater than, so it should be above your lines. So it's everything above. I want you to attempt this video or this problem by yourself. If nothing else, rewrite the equation and state the transformation first. So if I rewrote my equation, this is what it would be. I have to add 4 to both sides. From this, I can see that I have a vertical stretch of 2. That means that's my slope. I went right 4, because again, on the inside of the equation, it's always opposite. Or right 1, I should say. And up 4, because on the outside, it's what it is. So from this, I wrote my vertex. And because of this sign right here, I know that should be solid because there's a line underneath. And y is greater than, so that means above. So the first thing I'm going to do is plot my vertex. So left 1, up 4. 1, 2, 3, 4. And then I'm going to plot my other 2 points. I can see that I should have made my graph go up a little bit more. So it's going to be a rise of 2, run of 1. So up 2 over 1. Up 2 over 1. It's a solid line, so now when I draw my V, I should have a solid line written. And it's above the line. So in this case, since it's a V, above this line would be everything in between the V. If it were below, it would be everything outside of the V. And that would be your graph. So now if I gave you a graph, you would have to write the inequality. The things that you should be looking for when you're writing your graph, you should find the vertex. You should also find the slope. You should write down if it's dotted or solid. And you should also know if it's above or below the line. So when I look at this, this is my vertex right here. That means I went over 3, positive 3, and I went down 2. I'm also going to find my slope. So here's a point and here's a point. So I have a slope of 1 over 1. So my slope is just 1. So I'm going to just write a y and then a space. So my slope is 1. You don't have to include your slope there. If you want to, you can though. And the absolute value is x. And remember, the x is always opposite that's shown, so it would be minus 3. And the absolute value. And then minus 2. That's going, I got that from my vertex here. Now, since I know that it is dotted, and it's also above, y should be greater than this because it's above this equation. And since it's dotted, I just leave it greater than because there's no line because it's not solid. And that would be my equation. Here again, you need your vertex, your slope, state if it's dotted or solid. I want you to attempt this one by yourself. So my vertex here is going to be negative 4, 3. You have to be careful on this problem right here. I'm counting by 2's. So my vertex at this point, that's left 4, because each box is worth 2, and up 1.5, so that would be 3. So when I'm writing my equation, this would be y, and also I'm going to leave a space. My slope here is 1, because it's a rise of 1, run of 1. I'm not going to write that this time. So x is always on the inside is opposite that's shown. So since this is negative 4, this would be a positive 4 here. And it's moving up 3. So now one thing that has to be represented is the fact that this is flipped. So even though my slope is 1, I still have to put a negative out in front here. You could put a -1 if you want to show that it should be flipped. And this right here is going to be no line underneath because it's dotted. And it's above this line, so y again would be greater than this equation. And that would be it. Make sure you took very good notes and have a great day.